Okay, the questions I asked you to do last night were on page 459, and they were just finding the components. Okay, so number 1A says a position vector 16 meters at an angle of 75 degrees. So draw your XY axis. 75 degrees would be in here, and it's 16 meters, and this is 75 degrees. So really it's just asking you to find the legs. So there's going to be a Y and there's going to be an X. Okay, so X will be the adjacent side, so cos of 75 should equal X over 16 meters. X should equal 16 meters times the cos of 75. And when you punch this in your calculator, you should get X to be 4.14 meters. Okay, and that would be to the right. Y should be sine. So sine of 75 will equal Y over 16 meters. Y will equal 16 meters times the sine of 75. Punch this in your calculator and you should get 15.45 meters, and that will be up. Can't really say east or west, east and north, because it's really all we know is right and up and down right now and right and left. So that's A. B is an acceleration of 8.1 meters per second, angle of 145 degrees. So 145 degrees is going to be in the second quadrant, and it's going to be over here. So this is 145, but of course you need to find the reference angle, because this will be your X and this will be your Y. Doesn't matter that it's an acceleration, it's just a vector, right? Doesn't matter what the units are. So we still have our hypotenuse, and what is the reference angle going to be? It should be 35 degrees, right? Because they have to add up to 180. So looking at this, X is going to be cosine again, so it'll be cos of 35 is equal to X over 8.1 meters per second squared. So X will equal 8.1 meters per second squared times the cos of 35. Punching that in your calculator, you should get 6.635 meters per second squared, and this time it's going to the left. And Y should be sine, so sine of 35 should equal Y over 8.1 meters per second squared. So Y should equal 8.1 meters per second squared sine of 35. And when you punch that into your calculator, I think you get 4.65 perhaps meters per second squared, and again that will be up. So that's B. C is a velocity of 16 meters per second, an angle of 225. So 225 is going to be down here, right? So this whole thing is 225. So reference angle will be in here. This was, what was it? 16 meters per second. To here is 180, so this should be 45. My Y, my X. So again, X is going to be cos. So cos of 45 is equal to X over 16 meters per second. X should equal 16 meters per second cos of 45. Punch this into your calculator and you should get 11.1, maybe 11.3. 11.3 meters per second, again going left. Now you might realize that Y should be the same, because perhaps from your math last semester you know the sine of 45 and the cos of 45 are the same thing, but even if you don't, then it'll be 16 meters per second sine of 45, and when you punch this in your calculator you'll get 11.3 meters per second. The direction this time will be down. Number 1 is done. Number 2 is exactly the same thing. They're just giving us the directions in a different way. So this time they're using our north, south, east, west instead of the Cartesian coordinates. So 2A says 20 kilometers north 20 degrees east. So north, and 20 degrees east means if it's less than 45, it means you don't go as far in the second direction as you did in the first. Okay, so here's my resultant. It's 20 kilometers, and this angle from the north, 20 degrees east. This will be x, this will be y. Whoops, 20 degrees, I should make my 0 a little bigger. Okay, this time, check it out. X this time, it was north 20 degrees east, right? Yeah, x this time is going to be sine. So sine of 20 will equal 20x over 20 kilometers. So x will equal 20 kilometers. Sine of 20, x will equal 6.84 kilometers. And now I can use east because they're using east. And y should be cos. So cos of 20 equals x over 20 kilometers. X will equal 20 kilometers. Cos of 20. Do the math. X should equal 8.79 kilometers, and it is going north. Okay, so that's A. B. B is a velocity vector 3 meters per second, east 30 degrees south. So first you're going east, then you're turning and going south because the angle is only 30 degrees. The second one isn't going to be as long as the first vector. So 30 degrees, 3 meters per second, and you're looking for x and y. X is back to being the adjacent side, so cos of 30 degrees is equal to x over 3 meters per second. So x is equal to 3 meters per second cos of 30. Punch this in your calculator and get x to be 2.598 meters per second east. Y is going to be sine of 30 equal to y over 3 meters per second. Y will equal 3 meters per second sine of 30. Sine of 30 is just a half, so y is equal to 1.5 meters per second, and that's south. B is done. C is velocity vector west 70 degrees north. So west, and then this time the angle's bigger than 45, so my north needs to be longer. So west 70 degrees north. So this angle in here is 70 degrees. This is my y, this is my x, and this is 6.8 meters per second. My x is my adjacent side again. So 70, x over 6.8 meters per second. So x should equal 6.8 meters per second times the cos of 70. X is going to equal 2.33 meters per second, and it's going west. Y should be sine, so sine of 70, y over 6.8 meters per second, y 6.8 meters per second, sine of 70, punch it in, you should get 6.39 meters per second north. Okay, so then the only one left is number 3, and number 3 talks about this big story. Hot air balloons drifted 60 kilometers east, 60 degrees north. East, imagine my paper didn't just move. 60 degrees north will be up like this. So here is my resultant. This is 60 degrees, and it says it's drifted 60 kilometers. So then it talks about, lands in a field beside a road, runs the balloonist radio back, someone to come and get it. All that mumbo jumbo, really all it wants you to find, x and y. Okay, so x is the adjacent. Cos of 60 should be equal to x over 60 kilometers per hour. X should be equal 60 kilometers per hour. Cos of 60, going to run out of time. Y should be sine over 60. Again, cross multiply.